Welcome to this demonstration of Spectracom's GNSS simulator, the most powerful and affordable way to test GPS receivers. Let's have a look. Spectracom's GSG 5 and 6 series simulators are compact benchtop instruments. They're easy to set up, and the front control panel makes it easy to configure test parameters. You can connect a transmitting RF antenna for over-the-air testing in a shielded location, or connect the unit's RF output directly to the receiver. Notice the simple 3-item main menu. The last used simulation parameters are loaded and available to run a test by pressing the Start button, or the Enter key when Start is selected. To change parameters or create a new scenario, go to Select and choose any of the previously saved scenarios from the list. You'll see a series of configuration settings. Start by setting the date and time. You can enter manually or obtain the current time from an NTP server. Set the duration for the simulation. The unit can run continuously for up to 31 days. If you select the loop symbol, the unit will run for the specified duration and then restart the scenario. If the infinite symbol is selected, the unit will run continuously. Note that the infinite duration mode requires an internet connection. Enter the starting position using latitude, longitude, and altitude. The default format is degrees and decimal minutes. To enter the information in a different format, press the Format key. You can also enter the position in Earth-centered, Earth-fixed format. When done, the View button brings you to the next group of settings. Here, choose the number of satellites to generate for each GNSS system. These and several other features are dependent on the unit's configuration. In this model, the GPS and GLONASS constellations are available. Selecting Auto will generate the maximum number of satellites based on the number of channels available. The unit will generate up to 3 satellite-based augmentation system signals relevant to the location that you've selected. You can set an elevation mask so the unit does not generate any satellites with an elevation below a certain angle. Next, choose the signals transmitted by the satellites. L1 course acquisition is the commercial GPS signal. L1P and L2P are the precision-coded signals used primarily by the U.S. military. The real P-code signal is encrypted and called PY code. The signal transmitted by this unit is not encrypted but can be used to test an unkeyed receiver. Pseudo-PY generates P-code signals scrambled by noise. This provides a spectral representation of the PY code as seen by a receiver, but it cannot be decrypted. Still, it provides a valuable test of receivers without the need for handling classified keys. For GLONASS, you can choose to have the data transmitted on L1 and L2 frequencies. To configure a multipath signal, set the number of multipath signals in the scenario to 1 or more. You'll use this submenu to set multipath signal properties. In this case, satellite signal number 1 is duplicated with offsets applied to test the receiver's susceptibility to such a signal. You can choose to apply a fixed offset or a changing offset to 3 parameters: range, which is a change in time, Doppler, which is a change in frequency, and power. To configure one or more channels to act as an interferer, set the number of interference signals in the scenario to 1 or more. Configure these signals to be a satellite that does not match one that would normally be transmitted according to the almanac, or set an unmodulated carrier to act as a jamming signal. The power level and frequency offset for this interference signal can be set separately from the other satellite signals in the scenario. The next set of scenario parameters involves setting the trajectory. Trajectory describes the movement of the receiver under test. Static indicates no motion. Choose a factory-supplied or custom trajectory, or select the built-in circle trajectory to simulate movement. Determine the circle trajectory parameters by setting its diameter, speed, and direction of travel. Ephemeris is the information that determines what satellites are generated based on their orbital path and the simulated location. You can choose the default ephemeris built into the unit, or connect the unit to the Internet and automatically download data from the official NASA FTP server, or use custom-created data. You can select an antenna model to simulate a particular receive pattern. Several antenna models come with the unit, and you can install your own custom patterns. You can create an event file to script various satellite events to occur during the test, such as power fades. You can schedule a leap second event to occur at the next possible date, June 30th or December 31st. The almanac is updated to reflect the upcoming leap second. If the scenario is set to include a leap second, on the occurrence date, the receiver under test should display either the extra second or skip a second, depending on whether +1 or -1 is selected. On the last configuration screen, the ionosphere and troposphere are modeled to simulate the propagation delays of the signals through the atmosphere. You can set the temperature, pressure, and humidity for the troposphere model. When you are finished modifying your parameters, select whether to save the changes to the current scenario or save it with a new name. The unit will compile the information and begin to run the scenario. When the scenario is running, the front panel will display an overview of the transmitting signals. You can observe current time, speed, heading, and elapsed time. View the location in different formats by pressing the Format button. Pressing the View button displays more information about the simulation. This view gives information about the individual satellites being transmitted. An R indicates a GLONASS satellite, and a G indicates a GPS satellite. An S indicates an SBAS satellite. A D after a satellite indicates a duplicate signal in the case of a multipath scenario, and CG is an interference signal. Pressing the arrow keys while power is highlighted will change the power for all satellites in the scenario. Highlighting an individual satellite's power level will display the signals that satellite is transmitting. You can use the arrow keys to change the power level of that satellite. The final view shows the sky plot of the satellites being transmitted. Let's compare these to the satellites being received. In this brief demonstration, you've seen how the Spectracom GSG Series GNSS simulator enables fast, easy, and comprehensive testing of GPS receivers. With Spectracom GNSS simulators, you can test more parameters more often right from your bench. Contact us to learn more.